Hi, um, today I'm presenting the paper as called Does a Fish Need a Bicycle? The case for an on-chip MPU in the DBMS. This is from the CIDR in 2026. Um, so first we're going to talk about what is this paper and the key findings and contributions and related work, evaluations, methodology, performance, and the two concerns that I have from this paper, and the two improvement point I think that could be new directions, and the revealed thoughts. So first, this research explored whether the database management system should leverage the neural processing unit, the NPU, integrated directly into the CPU to accelerate the AI task. So, traditionally, in database, ML relies on the discrete GPUs, but these are not only hindered by cost and energy, but also due to the PCIe, the peripheral components interconnect express bus speed problem. So from a technical standpoint, the PCIe use a transaction layer that encapsulates data into the TLP. So this protocol introduced significant fixed overhead due to the harder processing and the bus abbreviation. So for the small frequent query comma in the database, this logistic cost result in a high initial latency. So making discrete accelerator inefficient for real-time task. Thus, with the rise of the NPU on the chips, that integrating on with the CPU, that's also called the SoC, system on the chips, that can do the near data computing to avoid the physical transaction speed problem at the PCIe, draw the attention of the people. So in this paper, also explore the opportunity that whether we can leverage the NPU features of the near data computing to realize the low latency and a small scale high frequency in the AI DBMS. The tasks such as the in-database ML, we can avoid the slow data transfer. So here we count the key findings um, and the contribution. The author identifies that the on-chips NPU offer the near data computing advantage that I mentioned before. This is primarily due to the integration of the SRAM, also called static RAM. So to be technically precise, the SRM utilized the 6 transistor latch circuit to store each bit. It's unlike the DRAM. It does not require periodic capacitor refreshing, which allows for deterministic ultra-low access latencies of approximately around like 1 nanosecond. The author demonstrate that for learned indexes, uh, I just gonna brief it, which is a kind of like a new algorithm to the search key that use regression and the neural network to replace the traditional methods as the B tree or hash map that outperform the traditional method like the smaller memory occupation around 90% and the lower time complexity around 70%. So let's circle back to the NPU. The NPU achieve the inference latency between 0.01 ms and 0.2 ms. So that's significantly outperforming the discrete the GPUs that must across the PCIe bus problem. So let's come to the related work. This study builds on the the on-chips functional unit like the Intel DSA. The DSA stands for Data Streaming Accelerator, which offload the synchronized memory copies to reduce the CPU load. So it also draw from the concept of the TCUDB, a paper that published in 2022 in the SIGMOD. Um, uh, and according to that, relational operators like joins can be cast as a matrix to matrix multiplications by transforming data table into binary indicator tensor. So it provides that the ML hardware can be repurposed for core data logic. This paper takes that vision further by testing it on the latest consumer grade SoC architecture like the Intel Core Ultra and AMD Ryzen AI. So come to the evaluation and methodology. The author performed a comprehensive benchmark comparing for the hardware target in the Intel Core Ultra, the AMD DNX, and MX tensions, and also the NVIDIA 800, that's a GPU. So basically compare three NPU and with one GPU. So they tested a variety of the workloads ranging from raw matrix multiplications and LLM inference to end-to-end SQL queries. So this diverse setup allows us to see exactly where each architecture reach its physical limits. So in short, the physical limits of the on-chips NPU is hard capacity constraint of their integrated SRAM, which create a performance problem that when the data value exceed internal storage. So in summary, the physical limit revealed by Q1 to Q3 here, the NPU are precision tool, not bulk handler. So they are highly efficiency for like micro task, like learn index that fits is entirely within the SRAM. But they fail to scale for standard database operators where the data logistics need to contact with the memory, like external memory. So that become the primary bottleneck.